Are you interested in RC planes?
Yes, I've always wanted to be part of the RC community, but I just don't know where to start.
Do you have any interest in RC planes?
Yeah.
But do you know how to build one and how they actually work?
No, I've never built an RC plane before.
Well, this is actually a very common problem. The RC airplane community is actually really hard to get into. It's expensive to buy a pre-made plane, and then if you want to build your own, it's actually really hard or just as expensive as just buying a pre-made one. And some people just want to be able to fly, other people want to learn how to actually make a plane, why they work, and all of the beautiful things behind it. But our wonderful team is trying to make an open source plans and code so that anyone can take some Arduinos and a little bit of money, some foam board, and be able to build a wonderful plane and get to learn all of those valuable skills. And this is for anyone from ages 8 to 100, maybe even 120. As we can see, the plane does actually function. You can move it down, and we can actually turn it as well. So we can taxi and we can take off. Ready?
Yeah, I'm recording. Yeah! Stop.
So here we have our controller. So to start it up, we will hit this green button, and then we can press the white button for the lowest potentiometer and the highest potentiometer. And now it is connected to our plane, as you can see here. We can move in, and on the plane, you can see it is all made out of foam board. You can see the cross section of the wing. It's just a few layers of foam board. We have our couple drone ESC motors, and these were taken from a Phantom 1. Inside, you can see the Arduino, and that is our Uno R3, our 9-volt battery. And then our NRF24s, our ESCs, are back there. So we can go and plug in our motor here. And we can see that if we turn on the potentiometer, we turn on our throttle. And then we also have control of all of our servos, and we can also steer without the plane actually moving. That's it, yeah. So here we have our beautiful wiring diagram. This is our wire diagram for the controller, so we can see our joystick here. And this is wired into our Arduino Uno. We also have our potentiometer, and those are on our analog input pins. And then up here we have our NRF24, which is what's going to be sending data. We also have our buzzer, which is going to let you know that the controller's on and working. And we have our buttons for our trim, and we actually have them color-coded, and those are all going into our just regular pins. Over here we have our plane wiring diagram. So we have our Arduino Uno running it. And then we have our two servos. This is for our elevator and our rudder. And then we have our NRF24. This is wired the same way as on our previous module. Then we have our 12-volt battery, and this is actually a lithium-ion or lithium polymer battery. We have our current sensor wired in, and this will be powering both of our motors. And then our motors will get power from the battery, and then we will have them power the actual motors. You will notice the two wires are actually flipped because one motor spins one way and one the other. And that is our total wiring diagram.
Here we have our flowchart for our code. So we have a controller with a joystick, some trim buttons, and then a throttle lever. Each of these values go put into a calculation on the controller. After the calculations are done, they go to a radio transmitter. The plane receives all those values, and then they put them into the elevator, rudder, and motors, and that's just how the code flows. On our controller code, most notable piece of code is our motor function. This allows us to do calculations for the motor, whether it is taxiing or flying in the sky or having differential thrust. Each of those values are there and calculated within this function. The next notable thing would just be our trim buttons. So right down here we have our adjusting trim buttons, and each of these, like the white button and the red button and the green button and the blue button, all do something different to trim either the elevator, the rudder, or the differential power. And then the rest of it is just using those functions and sending code over the radio. So over here we have our code. So the important parts that we have are the constraints for the elevator and rudder. That's to prevent the servos from stalling. And we also have our current sensor, so we can tune the amount of the throttle for the current to be in a safe range for the lithium ion battery when we use the lithium ion.